Let us begin with the last lesson in cryptography. In this video, we will discuss what is hashing, importance of hashing, and types of hashing, that is MD5 and SHA. A cryptographic hash function is a hash function which takes an input like a message and returns a fixed size string of bytes. The string is called the hash value, message digest, digital fingerprint, or checksum. A hash function is a mathematical function that converts a numerical input value into another compressed numerical value. The input to hash function is of arbitrary length, but output is always of fixed length. An ideal hash function is a one-way function. For every input, there is one unique output. Two different inputs cannot result in the same output. The ideal hash function has three main properties. It is extremely easy to calculate. It is extremely computationally difficult. It is extremely unlikely that two slightly different messages will have the same hash value. A real hash is a many-to-one function. There is a possibility that more than one inputs can result in the same output. How good a hash function is analyzed by checking the probability of more than one inputs having the same output. The lower the probability, the better is the hash function. Now, let us discuss hashing function with a simple real-life example. Alice possesses a tough math problem to Bob and claims she has solved it. Bob would like to try it himself, but would yet like to be sure that Alice is not bluffing. Therefore, Alice writes down her solution, computes it, and hashes it and tells Bob the hash value, while keeping the solution secret. Then, when Bob comes up with the solution himself after a few days, he can verify Alice had a solution earlier by calculating the hash and check that it matches the hash value given to him by Alice. This is a real-life example of hashing. Now, we will go back to the diagram shown on your screen. Here, an image of cat is put into hashing function, which is a one-way function, and we got a 32-bit hashed value which we just can't understand. In the message, "I love cybersecurity," you can see that the input and output are not same. Like, you can have any input, but output will be of the fixed length. In another message, "Welcome to cyber world," the output value is just "we can't understand anything." Therefore, we can claim that hash function is secure. Let us discuss types of hashing algorithms. We will discuss MD5 and SHA. MD5 was most popular and widely used hash function for quite some years. The message digest family comprises of hash functions like MD2, MD4, MD5, and MD6. It was adopted as Internet Standard RFC 1321. It is a 128-bit hash function. MD5 digests have been widely used in the software world to provide assurance about integrity of the transferred file. For example, file servers often provide a pre-computed MD5 checksum for the files, so that a user can compare the checksum of the downloaded file to it. In 2004, collisions were found in MD5. An analytical attack was reported to be successful only in an hour by using computer cluster. The collision attack resulted in compromised MD5, and hence it is no longer recommended for use. Next is the secure hash function, that is the SHA. Family of SHA comprises of 4 SHA algorithms: SHA0, SHA1, SHA2, and SHA3. Though from the same family, they are actually structurally different. The original version is SHA0. A 160-bit hash function was published by the National Institute of Standards and Technology (NIST) in 1993. It had few weaknesses and did not become very popular. Later, in 1995, SHA1 was designed to correct alleged weaknesses of SHA0. SHA1 is the most widely used of the existing SHA functions. It is employed in several widely used applications and protocols, including Secure Sockets Layer, that is the SSL security. In 2005, a method was found for uncovering collisions for SHA1 within practical time, making a long-term employability of SHA1 doubtful. SHA-2 family has 4 further SHA variants like SHA-224, SHA-256 and SHA-384 and SHA-512 depending upon the number of bits in their hash value. No successful attacks have been yet reported on SHA-2 function. Though SHA-2 is a strong hash function, though significantly different, its basic design is still that follows SHA-1. Hence, NIST called for a new competitive hash function. In October 2012, NIST chose the Kichek algorithm as the new SHA-3 standard. Kichek offers many benefits such as efficient performance and good resistance for attack. Therefore, SHA is stronger than MD5. Now, let us discuss applications of hashing with some real-life examples. The first is password storage. Instead of storing passwords in clear, mostly all processes store the hash value of passwords in the file. The password file consists of a table of pairs which are in the form user ID, hashed password. An intruder can only see the hashes of passwords, even if he accesses the password file. He can neither log on using the hash, nor can he derive the passwords from the hash value, since the hash function possesses the property of pre-image resistance. Next is data integrity check. Let us consider an example. Like I am going to download, let's say, a pirated version of Windows 10 from a friend of mine. But I know that my friend is a crook and he might have tampered with the ISO file. So I take the hash given in the Microsoft's website and compare it with the file he is giving. These prominent applications of hashing algorithm.